Hi, everyone. Just want to welcome everyone to Lives on the Line, Public Safety Distributed Antenna Systems, presented by Parallel Technologies. I'm Maddie Olson. I'm the Marketing and Communications Specialist here at Parallel, and I wanted to thank you all for joining us today. I know you're all pretty busy, so we appreciate you taking some time out of your busy day to spend with us. Today's presenter is Phil Leaf. He's our DAS Solutions Architect. We have a live Q&A going here, and Phil's going to stop to answer any questions that you may have on the presentation. So feel free to ask away, and I will be moderating the Q&A. So we'll just get rolling here. Phil, whenever you're ready, you can kick it off.
Awesome. Sounds good. Thanks, Madison, for that introduction. And again, thank you everyone for joining us here today. I know life's busy. We got some things going on. Hopefully this lunch hour is perfect time for everybody. So hopefully you got yourself a sandwich and a drink and you can kind of sit back and relax and just enjoy this little webinar with some good information. Mostly we're going to really talk about kind of our local area, as well as some other things. So just for our agenda for today, we'll do a quick little introductory of myself. We're going to talk about the emergency responder system. We're going to also talk about what it is, the importance of it, some of the building codes around it, at least for locally here, as well as what is Parallel's role in this solution. So as Madison stated, my name is Phil Leaf. I am the Distributed Antenna Solutions Architect here at Parallel Technologies. I've been with Parallel for just over 3 years. I've been in this industry for 10 plus years. DAS, telecommunication background, worked with a lot of the major carriers from Verizon, AT&T, T-Mobile, Sprint, as well as doing some FirstNet public safety, emergency responder systems. I also carry an IB-Wave certification here at Parallel. Some of those noteworthy projects is US Bank Stadium DAS, Wells Fargo Tower DAS, some Thrivent Financial, things like that. So we're going to jump right into what is an emergency responder radio coverage system, an ERRCS. An emergency responder system is a system for first responders in a crisis are able to maintain, communicate with each other, unified efforts. They're providing a more efficient response to an emergency situation. So we're not really talking just firefighters, we're talking everybody from our police, EMS, fire, Homeland Security. We're really talking about a lot of different parties when it comes to this type of system. And obviously emergency communications are needed during fires, natural disasters, security threats, much more. I'm sure you all can think of many scenarios where you would think, hey, when these first responders enter the building, I hope they're able to come out with a good resolution. So that's why we look at a reliable DAS system to be put in place to make the difference during those emergency efforts. The NFPA, the IFCA set regulations in most areas per local governments to ensure that some of these requirements and measurements are put in place and followed. So it's definitely a system that not just buildings are looking at, but we're having a national agency backing most of these solutions.
Hey, Phil, do you have a second?
Yeah, absolutely.
Yes, so we actually have a question already came through here. This attendee wants to know how do you know if you need a system?
Yeah, absolutely. You can really reach out to some of your local, fire marshals, fire inspectors to see if they're willing to stop by your facility, or you could reach out to people like Parallel, and we can come through and do do some signal readings, and verify whether if your building ultimately needs a system or not, or maybe you're building something new, and we can discuss a little bit further, and we'll get into that when it comes to some of the codes for each of your buildings.
All right, thank you.
Yeah. So someone asked, yeah, why do I need an emergency responder radio coverage system? Well, ultimately, this was put in place back during 9/11. There was many fatalities from that instance, and they went back and took a closer look at exactly why this happened, and ultimately there was a lot of communication that they found out was not being done on the same playing field, not on the same channel. So ultimately, during the 9/11 incidents, there was many EMS firefighters running into the building when some responders were actually calling out to get out of the building. But due to the multiple channels and radios, these first responders were not able to communicate to each other properly. And that is a big reason why these systems are actually put in place, especially for some of those high-rise buildings, as well as not only are these systems put in place for the first responder safety, but we're really also looking at the tenants inside the building. Who's occupying the building. I like to ask a lot of folks, when you go to work or when you enter a building, do you ask the front desk or the front personnel, is this building safe? Can first responders get in and out of it? It's not a question we really think of, or we go down the road of. So maybe it's something that we start thinking of a little bit further when it comes to our own personal safety, or maybe our kids' safety. I know as a parent that if I were to send my children off to a school campus, building of some education, and they were not able to have first responders come into the building and communicate safely, it would make me think a little bit differently about, when I enter that building, or who's entering that building. We're also going to take a look at the building terrain, the location, the construction material, height and size. Some folks have reached out to us before and said, well, I don't know why I would need this now. All we did was just a small little revamp to the building, and we would explain about such things as low-E glass that doesn't allow RF signals to penetrate through it, stopping sun rays and things like that, or the amounts of concrete that the building is surrounded by can affect a lot of those signals entering. So not only are we going to take a look at the codes and things like that, but we really want to take a look at how the building is made, the terrain, the area, are other buildings going up around it, blocking existing signals to not allow you to get back to the building the way you would want to see the signal penetrate. So the why is become a very big reason.
Phil, we actually have a question that was just submitted. If you could just pause here. So it looks like, I'm just reading this live here. Do all new buildings require an ERRCS, or just those of a certain size, configuration, or number of floors? It's kind of a multi-parter. So moving on, or is it a code requirement dependent on state or jurisdiction? Also, how does it differ from a DAS that is specific for boosting cell signals within a building like a hospital? That's a really good question, and I know it may be a little premature, but could you answer it?
No, absolutely. And we'll answer through how you kind of asked them there. So sorry, do you want to just reiterate that?
Yeah. So the first part was, do all new buildings require a system, or just those of a certain size, configuration, or number of floors?
Yeah, so not necessarily, and again, that's all going to defer to the area you're in. Really, the first thing we're going to do is look up the area you're in to see what those codes pertain to. So ultimately, that's going to be the deciding factor, where we reach out to the local code officials, inspectors, the authorities having jurisdictions, and immediately have a conversation with them around the building. Now, yes, size is going to be a thing. So if you're over that 6 to 7 story size, you're going to be deemed as a high rise, which most high rises are now being enforced and implemented. almost everywhere. Really, that's kind of one of the biggest concerns is that height. So yes, it's a yes and a no to that question. It really takes a little bit of navigating to come to find out exactly if you need it in your building.
So, and the next part of the question is it a code required depending on state or jurisdiction? I'm going to actually allow you to answer that on this slide here. So we'll just move to the final part of the question, which is how does it differ from a typical DAS system that is specifically for boosting cell signals within a building like a hospital?
Yep, absolutely. So the cellular system and the public safety system, they look a lot alike. We definitely separate the two systems. So we will have one DAS antenna system that will do all the cellular signals, and then we would have a separate DAS system that would do the public safety specific to the frequencies for the public safety officers. Yeah, you know, it's kind of something we actually really will talk about too in this next slide for the codes.
Awesome. Okay, well, thank you. Go ahead.
Yeah, absolutely. So as kind of we discussed there with the codes, each city, state, county is really adopting their own safety codes. They're definitely growing to adopt the exact same code. So for example, we're really seeing the East and the West Coast are a lot of the big players and being the push for a lot of these codes. So really, like the Midwest is following and looking at what the East and West Coasts have been doing and kind of following in their footsteps when it comes to really adopting the exact same code. As for Minnesota, Minnesota follows the Appendix P of the 2020 Minnesota State Fire Code. In there, you can find a lot of the emergency responder radio coverage. You know, we'll call it codes, guidelines, things like that that are needed to be followed. And we kind of talked about this. The code requirements differ from new buildings to existing buildings. Like I stated, some of those new buildings that are deemed as high rises, we're starting to see, you know, no ifs, ands, or buts. They need to have a system put in place. Some of the existing buildings, we see less restrictions to follow. We get to deal directly with maybe fire marshals to say otherwise. But some of the retrofits for the existing buildings, we're kind of seeing we're able to put in and not have to follow some of the exact codes due to some building restraints, maybe the age of the building, maybe the whole building is not even needed to be covered. We'll see a lot of existing parking ramps underground being pushed to have systems like this put in place. And then if we just highlight some of the code requirements, you know, starting from the beginning is, you know, the permit. You know, you need a permit in order to install these systems. You're going to need to take a look at the minimum and the maximum signal strengths inside and outside. Per Minnesota, we look at a neg 95 dBm. dBm stands for decibels per milliwatt of power. We're gonna see what it's like on the outside, so that as we bring that signal inside, we're balancing it properly to make sure we're mitigating any noise or any issues back on the tower for the first responders. System design, that's a really big one. We'll see a lot of these systems get over designed due to inexperience. So ultimately that system design is going to be a really big one to make sure that everyone gets their bang for their buck, as well as a system design that fits their needs. And then we'll also take a look at standby power. Things need to be put on backup generators, batteries, things of that such, anywhere from 2-hour, 8-hour, 12-hour to 24-hour, really depending on what your local codes are going to tell you and what you need to do. We see a lot of that 8-hour backup, so really that's the type of backup we typically look into, as well as house power. The next line we have there is the NEMA, the NEMA rated 4 type waterproof cabinets, and mostly always painted in red. You know, we want to make sure that a lot of these very expensive repeaters and pieces of equipment are protected, especially during you know, any sort of emergency, especially if there were to be even a fire. that you want to make sure that these cabinets and pieces of equipment are protected. Another one we look into is the qualification of personnel. We have specific licenses as well as certifications for a lot of these pieces of equipment to get them installed. We typically don't see your average, building maintenance installing these types of systems. And then we get into that acceptance test procedure, which we'll take a little look at a little bit further on the next slide. That's a big one that we're really seeing change in the last few years. Acceptance test procedures were done a little bit old school. We have some newer technology and equipment that allows us to provide these results better, faster. And then we're looking at that FCC compliance. The FCC compliance is not only with the pieces of equipment that are being installed, but we're also looking at an FCC license. Parallel carries an FCC license. It is being implemented more and more that if you're going to do any of these systems or testings, that you carry an FCC license so you can really understand the frequencies that are going around you in that area. And then we jump into maintenance, annual maintenance, repetitive maintenance. Ultimately, after these systems go in, sometimes they're forgotten about, and have the battery backups been checked? Has the system been updated? Do new frequencies or codes change? You got to make sure that after the system goes in, it's going to be maintained for a certain amount of time. And then we'll jump right into that testing and proof of concept for that said maintenance. They just want to make sure that at the end of that annual maintenance that everything still, checks the box as well as meets the code, and that nothing new is needed to be added maybe to the system. So next, we'll just take a quick look at how the surveys and testing is being done. Typically, in the past, we had seen a person come by the site with possibly a walkie-talkie or a two-way radio of some type with an authority having jurisdiction, and they would walk around the building, triggering the handset, trying to communicate outside the building. And that's kind of the way it used to be done, which was not the most effective. We found ourselves constantly going back to sites to take a look at things, but now we have scanners, we have devices that we're able to connect to that public safety system and take a walk around the building. The image you see in the top right corner is an example of a grid test and the plotting being done. That is of a passing system. Now, if the system did not pass, some of those little squares would go from green to red. And ultimately, when we walk around the building for the first time, a lot of these squares are going to be red, and it's expected. That's exactly why we're there on site, is to make this signal propagate through the building efficiently, as it should. So ultimately, I like to explain to a lot of folks that if you haven't seen a testing grid like that in the top right corner, and you have maybe had somebody come by and do a test for you, reach out to us. I'd love to see how they tested it. Data speaks for everything. So ultimately, that grid, that plot test that we do, it's really going to give us an idea for pre and post surveys of how to do the design, as well as prove to maybe the AHJ or the fire inspector that the system that was installed is efficiently emitting the RF throughout the building as we expected.
So Phil, just a quick note on the testing there. Obviously, a client doesn't have to have an existing system. You would just walk through with the scanner, and that would say whether they would need the system or not, right?
Correct.
Awesome, thank you.
Yep. Yeah, a lot of the times too, we find out that customers have us walk through the building and we only find a couple of sections in their building that do not get signal. And then we're able to maybe put in a very small system that allows them to take those areas and make them compliant. We also do have others reach out to us that have existing systems in the past, and nobody has been by in the last few years to do any maintenance or testing on them. So we will go through, maybe with this scanner and do a physical test of their existing system to show them maybe where their gaps in coverage are. So next we're going to talk kind of about that design for budget, as well as how is the system installed? How do we get started? So we're looking at that pre-design survey where I spoke earlier about walking around with the scanner to find those dead spots. Maybe we're walking the entire building. Maybe we get to the second floor of your building and we tell you, hey, we're starting to see very suffice signal up here. Maybe we stop at the floors below and we go back down and dive a little bit deeper into them. You can see on the right hand side we have our heat map as well as our logical design for the system. So we're able to come up with a feasible design that almost any construction company could help to install. So from there we're able to pick and choose what floors, what areas, what exactly needs to be covered. We also we're gonna understand what the local area code or the building is like. Again, we're gonna study some of the structure, from the concrete to the windows to the terrain outside. Are you on a hill? Are you down in a valley? As well as reach out to the local area code officials. If there's an inspector or a fire inspector nearby that we can reach out to and explain the situation that's going on. Typically we'll get them involved and find out maybe what frequencies they're using in the area or what they've been doing in the past to respond to emergency to these buildings. We've reached out to some that have said, oh, we have physical notes in our system that says when you report to 123 ABC Lane, everybody needs to change their walkie to this channel, or this channel when you're on the north, south, east, west. And as you can imagine, things like that take time. And when you're in the emergency situation, do you want your first responders, stopping to change the channel in order to properly save a life? So then we really get into that IBWave certified design. IBWave, or there's also another software out there called RANPlan. These tools are specific to RF frequencies or Wi-Fi, things like that you're maybe familiar to hearing about. IBWave RAN allows us to exactly provide that design you see on the right hand side there, from getting the exact footages of cable to knowing the exact amount of antennas, the size of the repeater that we need to put in place for that building. The IBWave is really helping mitigate 90% of the risk when it comes to the installation of the system. As long as you're an IBWave certified designer, you've worked with these RF tools before in the past, it's a pretty good tool that we can use to really come up with a budget, a design, a feasible tool for others to even take a look at before we even get to implementing the system. And then we take a look at our post-installation analysis, and we'd really talked about that on the last slide about our grid test, as well as our DAC score, our distributed audio quality. We're really going to take a look at a lot of different factors when it comes to turning the system on to make sure that we're not hearing any noise back on the tower. We'd heard some stories of some customers going out, turning these systems on, not being certified at all, and the police actually knocking on their door telling them to turn their system off because they actually blew up the amplifier back on the tower, knocking down 911 response for 4 hours, which obviously is a very big deal. Next, we're going to talk about the parallel approach. How is parallel involved? Parallel solution. Um, so ultimately, parallel is a turnkey emergency responder system provider. We provide everything from design, installation, support under one roof. It's, as I like to tell a lot of folks, it's a one hand to shake, one bat to pack. It's much easier to work with one company, where we're seeing a lot of companies tell us, oh, we're full turnkey, and then the company you called comes out to do their testing, and it's not the same company name that showed up, and the next thing you know is you're dealing with 2 to 3 different companies, and it's a little bit of a headache and a little more difficult to work with. Parallel carries Ivy Wave certified experts, RCDD designers, PMP, PMs, Bixie certified installers, constant managed scope, scheduled budget to meet your expectations. Managed services are, that is, in my opinion, the managed services after the install is done is also a really big one that we've got here. If you're going to have your annual maintenance, or you're going to have anyone stop in, you definitely want a number to reach out to in order to get somebody out to help fix any of these solutions or do the maintenance. We're constantly reaching out to customers, making sure, letting them know, hey, annual maintenance is coming up on these things. We just want to be proactive to let you know as your customer, as our customer, hey, we're going to get out there, we're going to do our due diligence, get that maintenance done, do that post testing for the concept, and get them on their way for another year of hopefully nothing but safety. And like I've said before, Parallel is built to absorb risk and remove the noise on your behalf, especially from those AHJs, those fire inspectors. We'll see a lot of new builds trying to deal with fire inspectors on these as an after the fact situation, because they weren't prepared. They didn't put a first responder system in. They now have the fire marshal at their door telling them they need to get it done. And a lot of the times they don't know where to go. They don't know where to start. Fire inspectors a lot of times don't recommend companies to do it, because that they just try to have, a little bit of a biased opinion when it comes to these solutions. So ultimately, as long as you're able to remember that Parallel can help provide that turnkey and mitigate most of those risks, that's exactly what we're here to help and bring to you.
Phil, we actually have a few questions if you have a minute here.
Yeah, absolutely.
One of our attendees wants to know if the system needs its own infrastructure, or can it run in any way within an existing DAS infrastructure in their building?
Yeah, that's a really good question. So, typically we would say no, we would want these on separate systems. What we have seen though in the past is that there are grandfathered in buildings DAS systems. We'll reach directly out to the fire marshal. We'll get them on site, or we'll get them on a call to discuss that location. And we have seen in the past where they do allow us to bring in the public safety repeater and connect it into the existing cellular DAS system. It's not extremely common. It doesn't happen a ton, but we definitely have seen it in the past.
Thank you. Another attendee wants to know if it's possible to install any type of system like this on their own.
Yeah, no, it's not a bad question to ask. The answer is most likely no. If you wanted to maybe pull some cable, or if you guys have on-hand low voltage electricians on your property, we could see us working in tandem with them. But ultimately, no. That FCC license, those skills that we acquire in order to design and implement, is typically done like a company like Parallel, and not by your typical building engineer or things like that.
Okay, thank you. And the last one we have here by another attendee says, how do they start the process of engaging Parallel?
Yeah, absolutely, and that's kind of coming up here on these next few slides. You can reach out through anything from our service number to if maybe you have an account rep, an account manager here at Parallel that you worked with in the past. You could reach directly out to them or tease it up very well for my next slide here. You can reach directly out to me. My contact info is here. My phone number's there. Call, text, email, whatever it is that floats your boat. Feel free to get a hold of me and let me know if you have any questions or concerns.
Thanks, Phil. So we actually have a couple more here. And as I'm asking these questions, for any of the attendees, if you think of anything while we're going through these responses, the Q&A is still open, so please submit those questions. Next question we have is training. Is there any training that's needed once the system is implemented, or is it pretty much plug and play?
So yeah, once the system is implemented and commissioned to all the proper frequencies, we typically take over most of the maintenance and things like that. Now, we definitely do some system training when it comes to some of these for building architects. If the system's not going to be tied back into the fire alarm panel, typically we will just show maybe building maintenance or IT that, hey, here's the visual alarm panel on the front. These are what each of these mean. If you guys ever maybe see one of these lights come on that you're concerned about, give us a call. We can come out. So when it comes to the training side, there's not a whole lot, but there definitely is a little bit when it comes to, where is your equipment located? What is each device? And what am I looking at when it comes to some of these alarms?
Great. Thank you. One more question here. So this person is wondering about the ongoing maintenance of the system, making sure that it's up and running. So I would argue that anybody who has our managed services right now could attest to the value of that. And you had mentioned that early in the presentation, but this sounds like a good answer to that. They're basically wanting to know, how do they know if the system's up and running? Like, in the future, a year down the line, if they have concerns that maybe it's not working, what can they do from there? Ongoing maintenance.
Yep, absolutely, and that's yeah, exactly. You could reach directly out to Parallel. You could try to reach out to a fire inspector. They're extremely busy. It's going to take them a very long time to maybe even get out to you if they're willing to get out to you. But really, engaging Parallel is maybe the best way to go about that. And we just come out with our scanner to and double check, and maybe we're in and out and we tell you, yep, it's on, running, looks great. Or maybe we come in and give you a few pointers and say, we found a couple of dead spots, or have you done any construction in these areas, or are these new walls put up? We'll typically find some of those things. Or we've come in also and seen a system completely shut off and that the power supply had died and nobody had checked it for a few years, and nobody had really known. So yeah, it's good to be curious when it comes to this type of solution. It saves lives, so I'd rather be curious and know that it's up and running for sure than take that risk.
Absolutely. Well, those are all the questions that I've seen come in so far. It looks like we don't have any more in our Q&A here. Phil, if you want to hit the next slide. I just wanted to point out our account managers here at Parallel. So you can see their information right there. If you have any questions at all, if you have an account manager that you're currently working with, feel free to reach out to them. If you don't have an account manager you're working with, feel free to reach out to them. That's what they're there for. All right, moving along. I just want to thank everybody for joining us today. This presentation has been recorded, so I'm going to be emailing a copy to everyone who's attended if you care to watch it again, or perhaps you want to share it with one of your colleagues. If you think of any questions now that the presentation's over, again, please feel free to reach out to myself, Phil, or any of the account managers you saw on the previous slide, and we'll be sure to get them answered for you. Have a great day, everybody.